Hey guys, welcome to Programming Knowledge. In this video, we'll see what STL exactly is, why we need STL, and also what all we can do with STL, right? So, we'll take a very deep look at what's actually inside STL. And as I mentioned in the previous video, STL is nothing but the abbreviation of Standard Template Library, and from the previous video you already know what template is, right? So templates are a way in C++ with which you can create generic classes and functions. Generic in the sense you don't have to specify a data type, you don't have to overload the function. The generic function can take any data type and process any data type, right? So standard template library is, you can say, it's a library of such templated classes and functions. And what is inside this? Well, all these functions and all these classes which I'm talking about, which are present inside the STL, are mostly data structures, right? So data structures and algorithms. Algos. I'll just write algos, right? So algos. Now, what are data structures and algorithms? Well, data structures, as the name suggests, is just a format, or you can say it's just a very specific way of storing your data. So each problem has its own solution, right? And each solution requires your data to be kept in a very specific way. So every problem you solve involves some processing of data, and a very specific data structure, or well, data structure is just a term, right? Data structure just refers to the way you're keeping the data. So you keep the data so that it becomes easier for you to access, and what I need to access depends on the problem. So if I'm working, let's say, if I'm making a software which can manage people in an organization, I need a data structure which looks like a table which maps people, right? So I need a data structure which can map people. But let's say I'm working on a software which just let's say organizes people in a queue, or let's say restaurant based software where first come first serve is maintained, right? So if you come first, I'll take your bill first, I'll take your order first, and then serve you first. So something like that, I don't need a map, I don't have to map people to their well, to the other people. I do need to map the people with their own orders, but I don't have to map the people along with other people. But in an organization, it is very mandatory to map the people, right? So I need to know who is working under whom, or who is working under well, who is working at the same level, or something like that, right? You're getting the idea. So that's when data structures become important. So data structures are nothing but a way of structuring data, and algorithms are nothing but how you handle the data, right? So there are different types of algorithms. So there are some sorting algorithms which basically sort your data, and there are some searching algorithms which help you search your data, and so on. So these two things primarily are what is inside the STL. And why do we need this? Well, say there are some data structures and algorithms which are very very common, and we'll be using them mostly in whatever problems we solve. So let's take an array for example. So array is a very very common data structure. Whenever you have a problem which involves a huge collection of people, you blindly go for an array or a vector or list. We'll see that vectors and lists are also kind of arrays, right? So these are all called containers, and we'll see what they are, right? But basically the point is, you have some very common things which you will be implementing again and again if you had to go for your general implementation. But what STL does is, it has all these common things pre-built, and they are highly optimized. So you don't have to think about optimizing these functions again. They are really highly optimized, and they are provided to you in a very ready-made fashion that you can just plug it inside your code, right? So that is the advantage of using STL. So the motto is that you don't have to reinvent the wheel. If you already have a common thing, well, if your problem requires you to create your own custom data structure, you have to. There's no other way. But let's say your problem just requires some common data structure which is generally used, right? And I'm not talking about only competitive programming. Well, people may think that STL is useful only for competitive programming because that's where data structures and algorithms come into play, but it's not like that. Whenever we solve any problem in computer science, we generally need a way to process data and we need a way to store data. And there are some common things and common methodologies people have come up across in all these years, and these common things are bundled up inside the STL for you to use them directly. Now, is this good? Well, it depends. If you are a beginner, then I would definitely suggest you not to use STL and go and learn how these things work, right? So this is more, it's more important for a beginner to actually understand how things work, and once you're at a level of recognizing how things work, you can go ahead with pre-built or ready-made implementations. But if you're somewhat intermediate or an advanced level programmer and you just want a language for its speed, right, you just want to quickly implement a solution, then you can directly use STL. There's no restriction on that. It's just an advice, but you can always use STL. It's already there for you. If you already know something and you're not wasting your time learning that same thing again and again, like let's say wasting your time to again go and see how these things are implemented inside some other language, that's complete waste of time, right? Because you already know the concept, then go for STL. But if you don't know how something works and you're just blindly using STL, that's bad, right? So just learn how these things work. You can use STL. It's a very good thing because, as I told you, it's already optimized. But if you're a beginner and you don't know something, try to come up with an implementation on your own, hands-on implementation, so that you actually understand to the core of how something works, and then go for STL, right? So with that being said, we'll just explore STL and what it has now, right? So STL has three main components. So it has containers and it has functions. Well, I should not say functions here. I'll just go with algorithms, right? We'll see what functions are, what I was talking about, right? But containers, algorithms, and then you have iterators. Now, what are these things? Well, containers are just a fancy way of saying data structures, right? So they just, well, they are containers for your data. You can just think of it like that. So the containers are nothing but your data structures. Algorithms, as you know, it's just your algorithm, way of solving a problem. And iterators, well, these are some special things. Well, you can think of it as pointers. For now, we'll explore more about that. But iterators are something like pointers which help you point to a particular data inside a particular container, right? So what you do, you use iterators along with a specific algorithm to manage data inside a container. So all these things make up a uh, complete program or a complete backbone of your program, processing backbone I should say. And then you have something which is like, this is kind of off, but you can just know about this. These are known as functors, right? So just like iterators, you have functions which are given as objects. It's objects, as you know, it's just an instance of a class. What is a class? It's a blueprint, right? So something like class, but it's just a function, but it's being treated as an object. So these are called functors, and we'll most probably just see the surface of it because it's not very commonly used. But these three things go together, right? And if you're interested, you can just go to what functors are. A very formal definition is available on the internet. You can go through that. But basically, functors are nothing but functions being treated as objects, right? So those are the contents of the STL. And in containers, you again have different types. In algorithms, you'll have different types, and iterators, you have different types. We're not going to talk about these two things in this video. We'll just talk about containers, and then in the upcoming videos, we'll see what iterators and algorithms are. Right? So algorithms are nothing special. They are just functions, right? You just import algorithms and you use the functions. So there's functions for searching, sorting, and all those things, right? Now we'll see what containers are. As I told, containers are just data structures, and there's types of containers here. As I told, there are specific data structures you use for specific problems, and containers are just that. They are subclass, right? So in containers, what you have is one type of container is known as the sequence containers. Now, what is sequence? Sequence, as you know, it's just storing one right beside the other. So a best example would be array. So array is a sequence container. And then you also have vectors. You come across vectors. You have lists. You also come across lists, right? And you have some other things like queues and all, which we'll be talking about, right? So there's something known as a deque, and we'll talk about what these are. You already know what vectors, lists are, and arrays are nothing but it's just a wrapper around your normal traditional array. So just how you create, right? So char array of something, right? So this is the same exact thing which array is, but it's just the STL way of creating an array, right? So that's there. And number two is the container adapters. Well, not container adapters. Let's first talk about the associative containers. So number two, let's say associative containers, right? So this is sequence containers again. Well, these are just types. You don't have to by head them, right? It's not going to be asked in an exam. Now, associative containers are basically containers which are made for searching. They are made for associating two things, right? As I told in the previous example, where if I had to maintain a software where I had to keep associativity between two employees, like I was talking about an organization, I need to know who is working under whom. So I need to create an association between each and every object inside the data. Then I'll be using associative containers. If I just want to store data, I'll just use a sequence container, right? Well, in associative containers you have sets, you have maps, and there are types of things, right? So there are some ordered sets, ordered maps, unordered sets, unordered maps, and we'll see what ordering and unordering means in a later video. But these are the different things you have in your associative container, and these are made for searching. So I'll just say made for searching in capitals, and these are made for access, right? So if, well, I say made for insertion and deletion, right? So made for updation, I'll just say updation, right? Now, what do I mean by these two statements? Well, whenever you want to frequently update your data, whenever you want to frequently insert something, remove something, or change the order of something, so then you use sequence data structures or sequence containers. So a best example would be in the case of a snake game, right? It's just coordinates of the body parts. I just want to maintain the coordinates, and I just want to keep on inserting and deleting and searching among them. So I don't have to use a associative container. I don't want to associate two body parts with each other. I just want to know that there are body parts. So then I use sequence containers. When do I use associative? When I want to search something, when I want to associate something with something, right? So then I use associative containers. And now the third is what I was talking about, the adapters, right? So container adapters, so these are nothing but, I'll just write it down, container adapters. So these are just different variation of your sequence containers, right? So examples of container adapters would be your queue, your stack, right? So these are nothing but, if you see queue and stack, both of these are nothing but arrays, right? So not even vectors, not even lists, both of these are just arrays, right? But the way we use them is different. So it's, you can say it's a specialized version of a sequence container, right? So those are container adapters. And you have types in here too. So like you have your unordered and ordered, as I mentioned before, but we're not going to go that deep right now, right? So those are the things you have in your containers. And coming to algorithms, right? So algorithms, you can just think of all possible things you can do with algorithms. You have searching, sorting, right? So I'll just write it down: searching, sorting, and what else do you have? You have a kind of array operations, right? So array operations, where you insert, delete, update, well, insert, delete, and then change positions, right? All these things. So you have algorithms for doing all these things in a very effective way. So I'll just mention it here. You can write all these programs on your own, but as a beginner, or as a very new person to this programming field, we won't be able to think of a very mathematically optimized way to solve these problems, right? So all these are mathematically measured, so there's something known as complexity of an algorithm, right? But basically the essence is that these are really efficient and optimized, right? And you should consider using them if there is some algorithm which is really common and which comes under these categories. That's inside algorithms. And then you have iterators. Iterators are nothing but a part of the containers, right? So as I told you, it's, you can think of them as pointers, which basically identify a very specific element in your inside your containers. So that's what is inside STL, and that's all about STL in this video, right? So from the next video onwards, we'll see how we can implement different STL components, how we can use different containers, different algorithms, what all options we have. We have already seen vectors and lists, but not very deeply. So we'll see what exactly vectors can do, what all it's capable of, what lists can do, and what deques can do. Well, deque we have used, so we'll see what deques can do and all those things in the next video. And we'll parallelly see how we can work with the algorithms along with these containers to get our problem solved, right? So that's about it in this video. Hope you enjoyed it. In the next video we'll start with the real stuff. We'll start implementing STL for some example problems, right? So till then, happy coding.